Okay, today we're going to look at section 3.3, properties of logs. First thing we're going to do is change of base formula, because let me pop my calculator up here real quick. If I have something like example number 1 that says log of base 3 of 16, I can't put that base number in there. Okay, so what you end up, because if you just do that right there, that's going to give you, that's really log base 10 of 16, but I really want the log of base 3. So in order to do that, we got to do some manipulating around, and it's called the change of base formula. And what that is you can change it to any base you want. You can change it to base B, to base 10, or to base E. Okay? Which if you change it to base E, that's really the natural log. So what this says is let A, B, and X be a positive real number such that A and B does not equal 1. Remember, your base numbers can never be a 1. This says it can be converted into any of the following ways. So what happens is, the way I look at this is I say this is the base number right here, so that goes down in the basement of the fraction. Okay, the base goes in the basement and the base goes down here in the basement. So I always do it that way, and then the number that you're doing is the one that goes in the numerator. So let's look at this one right here. Example number 1, it says evaluate each of the following using the change of base formula with common logs. Approximate to 4 decimal places. So you can change it to any base you want, okay? But since I have to approximate and do it on the calculator, I'm going to either do it to base 10 or natural log, because that's what goes on your calculator. So I'm going to do one of each here. So example number 1, I'll change it to log of base 10. So it's going to be log and log, and base 10 is the number there, and so we have the 3 goes down there in the basement of the fraction, and the 16 goes on top in the numerator. So if I put my calculator back up here, now I can do log of 16. Now a very important part is that you have to do parentheses right there, because you only do log of 16 and hit parentheses divided by log of 3. You can end that parentheses or not leave it there, that's fine. And you're going to get a decimal that is 2.5237. That rounds it up to the nearest 4 places after the decimal. That's a decimal point right there. Sorry for the sloppy writing there. Log base 5 of 22, for example number 22. So change the colors there. Now this time I'm going to do the natural log. Okay, so I'm going to do natural log over the natural log. Now which one goes in the denominator? It's always the base, because it's in the basement. Natural log of 5 in the denominator. Natural log of 22 up in the numerator. Let me slide this over here out of the way. So clear that off. I'm going to do natural log of 22. Remember to end that parentheses. Divided by natural log of 5. And hit enter. And we get, that decimal is 1.9206 if we round it off to the nearest 4 places after the decimal. Okay, now we're going to look at some properties of logs. We have a thing called, we can expand these things and condense them. That's what we're going to get into, but first let's start with some basic things. If you have the product property, is if you're multiplying log base of anything, let's say log base A of u times v. When you're multiplying here, what you really can change it into is two things being added together. The same exact base, but it's u, log base A of u plus log base A of v. Okay. The quotient rule, two things being divided. If multiply was add, divide is going to turn into subtraction. So it's the opposites there. Okay. And then the property rule is the exponent. The only thing that you look at, compare these two, this is a, really should be a u right here. It's a misprint there. Hopefully it's fixed on your paper. If not, please do fix that. But the exponent comes out in front. The n comes out in front right here. Okay? So the n, the exponent comes out in front, and then it's just log base A of whatever that number is. Okay? And it works the exact same way if you have logs or natural logs. It's the exact same rules, and the exact same things happen to those things. So let's look at these two examples down here. Write each log in terms of natural log of 2 and natural log of 5. So obviously we can get to 10 by saying natural log of 2 times 5. Now let's follow the product property up here. if you multiply them, you're really going to change that to adding. So we're going to do natural log of 2 plus natural log of 5. And that's all you have to do for that particular example right there. We just got to get it in terms of natural log of 2 and 5, and it is. And so we're done with that one. Now this one looks a little bit different over here. Natural log of 5 divided by natural log of 32. So let's follow the quotient rule. And the quotient rule says if you're dividing them, you can really turn them into subtractions. So let's do natural log of 5 minus natural log of 32. But we got to get in terms of natural log of 2 and natural log of 5. Natural log of 5 is good, but the natural log of 32 is a little too big still. But the good thing with this is 2 to what power would give you 32. So we have to think of 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th would give me 32. So natural log of 5 minus the natural log of 2 to the 5th power. Now, let's follow. We're going to do both of these properties at the same time here. Okay, we already did the quotient one. Now we're going to do the power property. Remember, the exponent just comes out in front. Now, this 5th power is just for this. It's not for the natural log of 5, so it's just going to come out in front of the natural log of 2, just to right here. So this guy's going to creep up right here in front. So it's going to be natural log of 5 minus 5 times the natural log of 2. Okay? And that's it for example 3 and 4. And now we're going to move into some that we're going to mush a lot of these things into one problem. Okay, now we're going to move on to example number 5 and 6. And we're going to find the exact value of these expressions without using a calculator. It's not too difficult. What we're going to do is we're going to write this 5th root of 7. That looks kind of different than what we've been looking at. Hopefully you remember from Algebra 2, but I'm going to just do a quick little review here. If I had the square root of 4, I could really write that as the root is the square root, it turns into 1/2 power. The denominator of your fraction is what the root is. And then the 1 is because it's taken to the first power here. Okay? So if I want to do like the cubed root of 8, that would be 8 to the 1/3 power. If I want to do the 4th root of 16, that would be 16 to the 1/4 power. What that means is, and this is, all these equal 2, by the way, because it would be 2 times 2 times 2 times 2 is 16, so the 4th root of 16 is 2. But you can write it as just the fractional exponent. Okay, so coming up to this one now, let me draw a line here. Coming to this one, we could have log base 7. Now that would be 7, and since the 5th power, that would be to the 1/5 power. Okay, and a couple of properties that we've talked about. The first one is the exponent can come out in front. Okay, so that would be 1/5 times log base 7 to 7. You can do it a couple different ways here, but let's just go about it this way. Now log base 7 of 7, remember those kind of cancel each other out, and all this just goes to, all this piece right here just goes to a 1. So it's really 1/5 times 1, which of course would just give you a total of 1/5. And that's it for that problem. Did all that with no calculator. Okay. Let's look at number 6. Natural log of e to the 12th plus natural log of e to the 5th. Remember from the previous page there, we had the product and quotient rule. Which one turned into a plus, and that was the product rule. So we could really just change this to natural log of e to the 12th times e to the 5th, because really meaning the plus really is multiplying these guys together. And so what happens there, that could really be natural log of e to the 17th. Remember, when you multiply, you add your exponents together. Now natural log of e. Okay, natural log is really log base e of e to the 17th. Now remember what happens if the base and the base both match up, those kind of just cancel each other out, and you're left with just what the exponent is, which is 17. Now with these type of problems, there's always several different ways you can go about it. Okay. Sometimes I do it different. If I'm looking at the piece of paper that's on my desk right now, I've did it a different way before. Okay, when I've done these notes before, you can go about it. You can change it to log base eve way up here, and get. If I did that, then the 12 and 5 would be left by himself, and you just add them together, you still get 17. But there's a lot of different ways you can go about it, and you're still going to get the same results. So let's go down here to example number 7 and 8 now, where we are looking at expanding each log expression. This is where we're really going to use those properties we talked about before, with the product and the quotient and that power, or the exponent one. Okay. So log, now remember, if there's no base number, that's understood to be a 10 there. So log base 10 of 3x squared y. All these guys are being multiplied together, so multiply would change into, say, log of 3. Multiply really turns into adding log of x squared plus log of y. Okay. Now we're almost done, but I do not want any exponents in my answer, because I know the exponent can always be pulled out in front. Now remember, it is only pulled out in front of that particular one. It's not pulled out in front of the whole thing. It's just pulled out in front of that one right here. So it'd be 2 log of x plus log of y. And that would be your result. That's expanding it out as far as we can take it, because every product and quotient or exponent is taken care of now. Okay, so now let's look at number 8, the natural log of this wonderful fraction here. Okay, what I'm going to do, I'm going to change that into natural log of 4x plus 1 to the 1/2 power, because remember the square root, it's the square root, so the 2 is in the denominator of that exponent, over 8. Okay, so let's change that. Get rid of the division part first. Divide really means to, get that far, divide means to subtract. Okay, and this exponent here can come all the way out in front, so it'll be 1/2 natural log of 4x plus 1 minus natural log of 8. It is important that you keep that in parentheses there, because you want to make sure you take the natural log of 4x plus 1. If you left off the parentheses, that just really means the natural log of 4x, and then that's a problem. So we want to make sure we keep that parentheses in that result right there. Okay, and that's all for that one. Now we're going to move on to number 9. Number 9, 10, and 11 is expanding these lovely things. Okay, I think this is the last page. Yep, this is the last page of it. So we just got through expanding them. We made the smaller into the bigger. Now we're going to take the bigger and go backwards and make them smaller. So what I like to do first is I like to take care of any of the numbers that are out in front first. Remember, the number out in front is really started as the exponent. So I'm going to take this guy right here, this 1/3, and I move it to the exponent of the x right there. So that'd be log of x to the 1/3 power. Let's keep the plus there. I'm going to do the 5 the same way. The 5 is going to be the exponent of all that parentheses there. So it'll be log of x minus 3 to the 5th power. Okay, and now if we're looking back at the product or quotient, we have a plus here, so we know that we can really multiply those guys together. Okay, now you can either keep it as x to the 1/3, or if you wanted to, you could write it as the cube root of x. No problem either way. Plus means multiply, so we're going to change that to multiply by x minus 3 to the 5th power. And again, it is important that you put parentheses around the whole thing, because you're taking the log of all that wonderful mess there. Now the good thing about this, we don't have to do anything else with it. We've taken care of all the plus and minuses, and taking the numbers out in front and change them into the exponents. So we have condensed that down as far as we can. We've condensed it from 2 logs down to only 1 log, and that's what our goal is. Number 10, we have 4 natural log of x minus 4. So this 4, remember, will go as the exponent right there. So it'd be natural log of x minus 4 to the 4th power. And the same thing with that 2. That 2 would go as the exponent of the x. Okay. Now again, minus here means if add means multiply, minus changes into your division. So natural log of x minus 4 to the fourth all over x squared. And again, we've changed it from 2 natural logs all the way down to 1, and that's as far as we can take that guy right there. Okay. Now the last one looks a little bit longer, not much harder though. Again, I always like to pull those exponents up first, so I'm just going to just rewrite it only using that property first. And you can combine things together more in one step, but I'm just doing it one step at a time, just so you can follow along with it pretty easily. So we take all those exponents and do like that. Okay. So adding means to now one thing you do have to be careful with is make sure all your base numbers are the same. This is log base 3, log base 3, log base 3. If it was a log 3, log 4, log 5, I could not do anything with those. Okay? But they are all base log of base 3, so I can go ahead and mush these things down to only one log. Adding these guys together, that would really means to multiply. If I just did that one step right there, that would mean that. Okay? And then, of course, the subtraction turns into division. So I have log base 3 of x cubed y to the fourth all over z to the fourth. And now we've taken that 3 logs and changed it all the way down just to 1 log. And that is the end of section 3.3.